Hi guys, Wire EDM is a great technology, but it's far from cheap and even DIY projects are expensive, so this video is the first step to make it affordable. It's a perfect example of what you can make with Wire EDM. It's an extruder from an old Under 3, and you can see that I cut straight through the brass, the aluminium and the stainless steel, while keeping the nozzle screwed in the aluminium so we can see the thread. The basic idea of Wire EDM is to create a spark between two terminals. This wire is connected to the negative terminal and the plate to the positive, and we use a pulsed power supply to create thousands of sparks per second, which will evaporate the metal on both ends. With this process, I can make a small cut which goes through the material, and you can see that the wire itself is damaged, meaning that the wire is a consumable. For the electronic part, we have an 80 volt power supply with the positive side connected to this fan capacitor and directly to the workpiece with this banana plug. And the negative side is connected to a high power resistor, then to the capacitor, and finally to the MOSFET. It is controlled by an Arduino, and the output is connected to the cutting stage by this cable. The negative terminal is connected with this banana plug to the extruder wheel. This wheel is pulling the wire, which is pinched by this lever. So I can just push it like that, and the wire is connected. The new wire is coming from here. It's pinched between these two bearings to maintain enough tension. Then it's going through these two nozzles, so the outer one is a water jet to clean the cut, and the inner one is a sapphire guide of 0.4 mm. Then we have two ceramic bearings, and to complete the loop, the wire goes back to the extruder wheel. We can see here that we have two spools. This is the waste spool with the used wire, and this one is full of clean wire. And we have two magnets which drive this spool with these iron nails. This system acts like a clutch to ensure constant speed even though the diameter are different. I just want to spend a tiny bit more time on this setup because it's the heart of the machine. So we still have the two levers for the wire. But the most complex part was to design a rigid frame which is steady enough to tension the wire, but also electrically insulated from it. You can see here that these parts are connected together, but they are insulated from the red frame. So it's done by bolting two aluminum pieces together. They are anodized and coated with a resin to provide a very good insulation. For the bearing, I choose some hybrid bearings. There is some ceramic beads instead of stainless steel, so we have a very good insulation between the two parts. And to keep the thing cheap, because these bearings are expensive, I just choose some 3D printed plastic around a stainless steel bearing for this part. And finally, we have the wire guide, which is in ruby, and it's a 0.4 mm diameter, which is just a tiny bit bigger than the wire. Apart from the obvious modification, I needed to improve the under 3 a bit. So I added a linear rail on each axis, because the water is quite heavy. I also used the extruder motor here, which I overdrove at 3 amps. And I added a 51:1 reducer on both axes. And the other one is back there. It's because the Wire EDM is a very slow process, and the NEMA 17 are too fast for this. And finally you can see the connection for the water pump back there. Now we can prepare a cut on Fusion. So first I go to the manufacturer tab, then I can create a new setup. I just align the axis for this piece, and then I can remove the offset so to have the appropriate height. Then I just need to do a cutting path, I select the contour, and I need to choose a tool. So for this process I use the water jet cutting tool, so set it at 0.3mm in diameter, it's the most suitable one. And then for the geometry it's done. For the height I put everything to 0. And the most important part is the linking. I just have to select one starting point on the material, and I will add a 5mm lead in at 90° angle, so it will go in the material of 5mm and then start to cut the path. Here you can see the path and it's good to go. We just have to generate the G-code. So I use this post processor, which is a custom-made processor based on the Weather post processor. And basically there is just two settings to tweak. I made a database for different materials with different feed rate and wire speed, and we can change it according to the machine, but for aluminium I have these settings and I just have to choose the material here, and that's all. I have the G-code and we can see here that it calculated the appropriate feed rate and the distance of wires that we need to use, and it will take approximately 35 minutes. So here is the final result. It took about 35 minutes and the dimensions are spot on, but the holes aren't perfect, so I need to improve this aspect. There are still a few points I'm thinking of improving. For example, the holes are not cylindrical, so I need to decrease the backlash. Also, I want to implement a closed loop control for the feed rate, like a commercial machine, so it can be faster. And of course, the machine can be safer and cheaper with a few mods that I already designed. I hope you enjoyed this video. If so, please don't forget to like and subscribe, and thank you for watching.